I thought I knew GIS, but this exam might prove me wrong. I decided to take the GISP practice exam. You know, the one that's supposed to test if you are a true GIS professional. I've been in this field for years, so I wanted to see how I would stack up. If you are not familiar, the GISP, offered by the GIS Certification Institute, is a process that allows you to prove your GIS skills by submitting a portfolio and taking a test similar to this one to receive this accreditation. But why go through all of this? Does the GISP actually matter? Will it make you more money, get you a better job, or just add some fancy letters to your name? Today, I'm putting it to the test. We'll break down what the GISP is, why people get it, and I'll show you my honest attempt at taking the practice exam. No sugarcoating, just me, my GIS skills, and to be honest, a whole lot of nerves. Well, let's see if I pass. Before we get into it, the GISP, or the Geographic Information Systems Professional Certification, is a credential that recognizes your experience and competence in the field of GIS. It's offered by the GIS Certification Institute, or GISCI, and is one of the most well-known certifications in the geospatial industry. But unlike other certifications, the GISP isn't just about passing a test. It's a combination of your education, work experience, and contributions to the GIS community. You submit a portfolio and then you take the exam. So why do people pursue it? Well, for some, it's about standing out in a competitive job market. Others might see it as a milestone in their career, a way to validate years of experience. And then there's the credibility factor. Having a GISP next to your name signals that you're serious about GIS. But the big question, is the certification right for you? That's what I'm here to find out. There are a lot of reasons why someone might decide to get a GISP. First, it can be a solid way to validate your experience and demonstrate your commitment to the field. Employers often see it as a sign that you've put in the time and effort to advance your GIS skills. For those in government, consulting, or large enterprise environments, having a GISP may be a requirement or at least a major advantage. It can also be helpful if you're looking to move into management or leadership roles where certifications are valued. There's also a networking aspect. Becoming a GISP connects you with a community of certified professionals, which can open doors to new opportunities. Now, on the other hand, it's not necessarily a golden ticket. In many sectors, practical experience and software proficiency might matter more than a certification. Especially in tech-heavy roles, certifications like AWS or Esri's technical certifications could carry more weight. So while the GISP can definitely add credibility, it's important to weigh whether it aligns with your career goals. For me, I want to see if I can just pass the practice exam, and by doing so, I hope to show you what's in the exam and help you understand if that's a step worth taking for you as well. So if you are thinking about getting your GISP, there are a few steps that you need to go through to prep for the application process. To begin the application process, you need to submit a portfolio that includes your education, work experience, and professional contributions. This means documenting your GIS-related projects, any volunteer work in the field, and conferences you've attended or presented at. The GISCI awards points based on these categories, and you need to meet a certain threshold to qualify. Next, you'll need to take the GISP exam. The exam covers a broad range of GIS topics, including data management, analysis, cartography, and remote sensing. It's designed to test your theoretical knowledge and your practical understanding. So once you pass the exam and your portfolio is approved, you'll officially earn your GISP certification. But that's not the end. To maintain your GISP, you'll need to earn continuing education credits by attending conferences, workshops, or additional training. It's a rigorous process, and depending on your experience level, it can take several months to complete. Some people even spend years building up the necessary qualifications before applying. And then, of course, there's the financial side. The exam fee is around $250, and the portfolio submission fee is another $200. This is for the US. This might be different depending if you live in another country. Plus, you might need to budget for study materials, training courses if you feel the need for extra preparation. And after that, it's $95 for the next 2 years to maintain the certification. So now that you know what it takes to get a GISP, let's jump into the practice exam and see how I do wish me luck. So if you want to take the test yourself, just Google GISP practice test or practice exam, and you'll see two links here. One requires you to fill out a Google form, but you can see the PDF here, which will then give you the access to the actual PDF. So you can actually use this and then get access to the test. Now what I did is I simply turned that into a Google Doc here, and then I'm gonna take the test as we go along here. So let's see how I do. We'll go through the questions and give it a shot. So let's jump into this. I'll be reading on my screen down here. So if I'm looking down, that's what I'm doing. So question number 1, when working with the data that's in UTM zone 19N coordinate system, what unit of measurement is typically used? UTM, if I remember correctly, is all based in meters. So I'm going to go with meters. So what is 35 degrees and 15 minutes in decimal degrees? So 15 minutes would be basically a quarter of the quote unquote hour, if that's the correct way to think about it. So that's going to be 35.25. So you need to convert point data from NAD 27 to NAD 83. What expectations should you have concerning coordinate values between the two horizontal datums? So if I think through this as I read the 4 different options here, there's basically 2 options that tell me coordinate values are likely not to be the same and coordinate values will remain the same. Conversion algorithms are so precise that there'll be no difference before and after the coordinates. And as the datums have the same ellipsoid, there'll be no adverse effect on the datums. So what I do remember about these 2 different datums, if I remember correctly, is that one is older and one is newer. So there's some sort of precision factor here. That's why they're different, even though they're kind of in the same thing, if I'm remembering correctly. So I have to believe that it's number or letter C, I should say. So I think they're not likely to remain the same, even though they're similar in some ways. It's been a while since I've done this once. This is kind of a guess here. I'm just going to go with that. I don't think that there's like a precision factor, even though they're in the same ellipsoid. One's older and one's newer. I believe that's the correct way of describing that. Which types of rasters are examples of discrete data? Well, I know that one. So there's going to be a couple of these where they are discrete in terms of absolute values, which means that there's not like smooth change between them. Like elevation can change at any point, temperature can change at any point. Soils are more absolute and zoning is definitely absolute. So I feel pretty confident about that one. You are gathering data to conduct an impervious surface analysis for your municipality. Which of the following should you use to best represent streets? So if it's about surface, we don't really care about center lines. So I'm going to get rid of A and B. And I don't think surfaces is the right answer either. So I'm just going to go with C because I think you want actual spatial information, like the actual space it encounters. So I'm going to go with C on this one, polygons. How does a TIN differ from a raster data model? Now, I haven't worked with TIN data much. I've encountered it very few times, but I do know it's a triangulation, if I remember correctly. Could be totally wrong there, but that's what I remember. It's sort of this triangular model. I came across that when I was writing the spatial SQL book. So TIN. So let's read these answers here. TIN and raster data contain uniform cell size. I don't believe that's right. Data sampling is more sparse, while TIN and raster contain uniform point spacing. The TIN sampling is more dense. TIN and a raster represent a surface. TIN contains irregularly spaced sampling points. I believe it's C. Just I think that's the right one. TIN and raster both represent a surface. They both represent a surface, and that contains uniformly spaced sampling points. I don't believe that's true. I believe that the TIN has different sampling points. The raster is a grid, so it's uniform. What are the following examples of topology rules? Select all that apply. Lines must have more than 2 nodes. Lines must not intersect. Polygons must have more than 3 edges. Polygons must not overlap. So I don't think there's like a hard rule on more than 2. Like a line can be 2 nodes and a polygon doesn't need more than 3 edges, but they can't overlap. They can't cross, because if I think of a topological map where you have these lines dividing, different numbers, they would never overlap. Just wouldn't happen. So that I think it can be both. You can have two different types for, like, if I think of like an elevation map, you can have polygons or lines. So I'm just going to go with those two. They can't overlap, they can't intersect. That seems right. So what is an example of quality assurance for geospatial feature collection? Okay, comparing collected features to high resolution imagery and open source feature data, conducting automated checks of features including topology and edge matching, developing standards, policies, and processes to be used during feature collection, manually inspecting collected features and attributes over a sample of the project area. I think it's A, B, and C. Oh, which is an example? Which is an example of quality assurance? So this one seems too limiting. I don't think it's that. And I don't think it's simply this. So developing standards seems to be the right answer there, not manually inspecting collected features. That seems like the right thing to me. So I'm going to go with C. You are converting a vector land cover classification dataset based on the Anderson system to a raster dataset. You want to maintain a certain level of accuracy. Which of the following should you consider when completing the conversion? I don't know the Anderson system, point blank. So I'm not going to pretend that I know which is the Anderson system to a raster data set. But if we have land cover as a polygon and need to convert it to raster, which of the following should you first consider when completing the conversion? Data preprocessing settings, I don't think that's right. Grid cell size, number of classifications, resampling of data. I think it's going to be grid cell size. I think that's the first thing you want to consider is how large is your grid going to be, and then that would basically tell you everything. The number of classifications kind of is less relevant there, I believe, but that's what I think is the correct answer on this one, 9. You are assessing positional error in points you collected using GPS. In the error distribution, the mean error is 15 meters and the 95% frequency threshold is 20 meters. Which of the following statement is correct about these? So the mean error, the mean is 15. That's the average basically. And the 95% frequency threshold is 20%. So that would tell me what? 50% of errors are between 15 and 20 meters, which no, that's not true. 5% of errors are greater than 20 meters. That would be true. 5% of errors are between 15 and 20 meters. No, that's not true. And 95% of errors are less than 15 meters. That's also not true. So it has to be C, or B, I guess, in this case. So I'm going to go with B. Which of the following are examples of core metadata concepts? Select all that apply. So I think experience level of the author is irrelevant. Points of contact, yes. Reference system, yes. And use constraints, how much can you use it? So it's just got to be these 3. I don't think experience level of the author has anything to do with it. So we're just going to cut that one. You're creating a new field in an attribute table that will store information by the hour in order to perform temporal analysis. Which field type should you choose? Date. That seems easy enough to me. When assessing a data set according to FGDC and ISO components of data quality, which of the following should you consider? Select all that apply. Yeah, this one, I don't know FGDC. I'll be totally honest. Again, I don't know what that is. I know what the ISO components of data quality is, so let's think about this one a little bit. So I don't think equipment vendor matters here. That doesn't seem to be right. I don't know if it's a logical consistency that just doesn't sound right, so I'm going to go with A and C, attribute accuracy, which makes sense, and then lineage. The graphical representation of map elements and symbols in order by order of intellectual importance, known as, I know this one. This goes all the way back to some of my early GIS education, but that is going to be A, cardinality. This would be really bad if I got that wrong, but I'm pretty sure it's cardinality. No, okay, no, I know. Cardinality is directions, so no. So I do know this one. I just jumped to it because it was like a term I remember. So, okay, it's not layer order, or it's the visual hierarchy. Cardinality is directions. That's pretty bad. Okay, I was way too confident there, but that's okay. That's okay. We're moving on. I know, final answer. I should D, visual hierarchy. All right, easy. Got too excited there. All right, when you're creating map data where the only source of information is from a 1 to 100,000 scale map, which statement is true concerning the relationship between the map scale and the accuracy in this case? So it's like where there's a smaller scale, it's larger error. Smaller scale is not smaller error. Smaller scale is larger error. So the larger the scale of the map, in this case, I think it's going to be this. Smaller scale, larger error. That's what I believe it to be. So we'll go with that. I'm pretty sure that's the correct case. Okay, which are the common conventions when choosing fonts and font colors for your map layout? Select all that apply. Categorize culture and physical features with differing fonts, if I remember correctly. Yes, I'm going to be a little less bold on my I know it statements. Label water features in blue font and italics. Generally, you would do that. Use the same font and font size for your print. Same font and font size from your print map in your web map viewer. I think that would be correct, but I would never use 3-point font, like ever. I wouldn't go below 6. I wouldn't go below 8 if I have to, but if I have to go to 6, like that's the lowest you should go, because then it becomes effectively in you can't read it. It's too small. So I'm going to say it's A, B, and C here, because you want to categorize them differently. Label water features blue and italics. I remember that. Same font size for the web map. That makes sense. You don't want them to be suddenly smaller there for some reason. Well, okay. Let me think about that again. Same font and font size for your print map. Well, the font on your web map can be dynamic, so you can change that. So no, I'm going to roll that back and just say A and B here, because you can change those. So I'm going to go with that. Which is not a type of map used to represent a surface, contour, network, shaded relief, wireframe. Network is a connection, so it's not surface, those are connections. Which is the most effective way to visualize elevation change along a polyline? Oof. I don't know. This is a complete guess on this one. I don't know. Aspect is identify, inversion, or profile. Oh boy. So visual elevation change along a polyline. Identify is just pointing it out, so I'm going to say no. Inversion, I'm not entirely sure what that means. Aspect is no. It feels like profile, where you're showing the profile along it, like if you're thinking like a Google Maps where you have like the elevation piece. Okay, you've received a legal description for a property. You need to generate a geospatial feature. What's the most appropriate method of data input? Legal description. So that's generally a text-based description, if I'm thinking of this correctly. And all of these, this is just a process of elimination, I think, honestly. Data input, so these are all kind of the same. I don't think you want to heads up digitize because it's text-based. Data input, you want to turn it into Euclidean. No, Euclidean is like distance-based. I believe it's if I want the data, I want it to be a coordinate geometry. I want it to be coordinates, proper coordinates, not a map of coordinates, not distance-based. Heads up digitizing, I don't think that's the right move. Coordinate geometry is what the data that I would want, so that's what I'm going to put in. We'll see how it goes. What's the minimum number of satellites required to calculate exact 3D GPS location? I believe it's triangulation, so I'm going to go with 3, although I'm not positive on that one. Okay, which is a limitation to consider when regarding the use of UAS, or unmanned aerial systems? Hopefully I got that one right. Platform range, areas of application, data processing tools, lack of available technologies. I would go with platform range because they're limited in terms of how far they can fly. Seems right. So all these other things don't seem like there could be limits, but not hard limitations. Open source data has the most limitations related to which of the following? Attribution, complete download, modification, or reuse. So generally, you can modify those data sets. You can reuse them and you can download them, but you do have to attribute them. So I'm going to go with A on this one. When exchanging geospatial data from one software to another, which is generally considered a best practice. Exchanging with zip files, I'm going to say no. Shouldn't be passing zip files back and forth. Converted to CSV, maybe password protection should be implemented, probably not. Underscores should be named. That is spaces in file names, just a bad move. So don't do that. Use underscores. All these other things are options you could use, but best practice underscores. Which of the following statements is true regarding XML files? XMLs are funky ones, markup language. So markup symbols in XML are considered limited and require definitions. The main intention of an XML file is to describe how information is to be displayed. That seems right. XML files are intended to be shared only between GIS software programs. It's not true. XML files enable the share and exchange of portion of database scheme is also not necessarily true. And this, with the way it's saying this, I think it's meant to exchange style data. So I believe it's going to be B in there. It's not necessarily limited, but it's should describe how this information should be displayed, I believe. Ooh, SQL question. I better get this one right. So you have a building layer called buildings. You want to create a selection of the buildings where the names start with best hotel. You create a SQL statement with the where clause with the building name equals exactly best hotel. Query return 20 records based on your examination of the table. However, you notice there are more. Which should you utilize to capture and improve all those results? So you want to use wildcarding, which in this case is going to be with a quote here. And so you're going to be using one of these. It's not C. I can tell you that right now. Not C. Star is a reserved character for select star. So building names starting with best hotel. So if they start with best hotel, you know that's correct, and then you just want everything after that, right? So then you also have an option for single spaces, single characters here, double characters. So it's either A or B. So the double quotes are reserved, I believe, to basically escape column names that technically have spaces in there. So you want to use single quotes here. So A is final answer. Is that the one you want? This one would retrieve anything that has best hotel in it, basically anywhere. So that's not correct. So it's based, and it also has a double quote, so that doesn't do us any good either. So it's A here. So your hints here are the single quotes and the percentage after it, or the percent sign that's after the end, which means that it's everything starting with best hotel and then any other result as the wild card after the fact. Okay, so what is the purpose of this formula? Just D equals the square root of x plus y, x2 plus y, x2 minus x1 squared minus y2 minus y1 squared. So this formula is used to calculate the deviation of a Cartesian coordinate system. It's used to calculate the direction between locations, both distance and direction, and only distance. So deviation I don't think is correct. It is basically direction or distance that we need to figure out if it's either of those or both. If I remember correctly, this looks like a distance equation, not a direction. Direction would have some sort of element to figure out angle, and we need some sort of something there. So this looks like the distance to me. So I'm gonna go with distance D. Final answer. This has now turned into an episode of Who Wants to Be a Millionaire. So, okay, we have another one here, which is an image that has yellow squares of zeros and ones here. The ones all correlate to positive numbers. The zeros correlate to a zero value or a negative number. Which of the following map algebra operator types is depicted in the graphic, where B is the resulting raster? So we have local, focal or neighborhood, relational, or zonal. So there's no arithmetic here. It's either, there's nothing there. It's not a neighborhood because you're not analyzing things around this. So I don't believe it's A or B. Zonal or relational. I believe it's relational because it's a logical or relational mapping between the two. Zonal would be something else. So I'm going to go with C as my final answer on that one. Okay, considering the two tables shown, you want to link together, combine the information into table one. What would be the appropriate process? We have a name, owner name here, and a pin, which is between the two. And there are multiple records for each pin. So we have 101, 102, sale day. It looks like it's basically the people that bought that. We're not appending relate. So union would be basically smashing the two data sets together. It's not that. Okay, so we have two tables here, and they want to link them. Link being the key word, I guess. So So it's not union, because union would be taking the two tables and kind of, stacking them on top of each other. We're not appending them either. So it's join or relate. Look, I know this is a table join. So relate just doesn't seem right. I just hope there's not some strange reason why we would be using the word relate here. But for me, that's a join. Plain and simple. Which part of a database table contains attribute, data, type, constraints? Fields, keys, records, or tuples. So tuples is data type. I believe it's the records, keys, or fields. So the records are the rows. That's not it. The keys would be just a route. I think it's going to be the field. So the field will tell you what is the data type constraint on that specific field. A lot of SQL questions here, which I wasn't expecting, but I guess good to know. You have two tables that can share a primary key and have a many-to-many relationship. What process should you use to link them together? This is the same question as above. It seems like many-to-many, right? You still would technically call this a join, I believe. I would call it a join. It's a type of a join. It's a right, you can do right, left, outer, inner. There's all kinds of joins, right? So many-to-many relationships. So you could join them anyway, and you can do a full outer join as well. But for some reason, if we call that relate, that's the only reason why that would be relate in this case. In my mind, I could get this totally wrong, but I don't know why you would call it relate, but hey, maybe it's called relate. Your organization has a satellite office that's experiencing connection performance issues when accessing its GIS database at the central office. So satellite can't get access to the central database. What is a valid method to resolve this? So I think it's transaction log. Like if you're inserting records and changing records, like inserts, updates, deletes, all that stuff, that creates a transaction log. You would want to share that, which would then tell the satellite database what to do based off of what took place between the downtimes at those different places. So you don't need to replicate the database or do anything like that. You don't need to read, I don't know what C is or anything like that. So I'm going to go with D as transaction log exchange here. So we have some pseudocode here. You can see that here. We have start, we have two inputs. We have an extent offset. So then you offset the min, the max of each one. You set the new extent to that and you stop. So that's the code is basically, I think, creating like a grid around a point for the most part. Pseudocode routine creates a map extent centered on a point based on the pseudocode which statement regarding the output extent is true, so that all coordinates are the same non-angular units. It is equal to the distance of the extent offset around each input pair, which seems to be correct. It's a rectangle whose width is equal. Width height is times 2. It's not true. Single line. No, it's not a single line. It's a square whose height and width dimensions are both equal to the extent offset divided by 2. So it's not divided by 2. It's just going to be equal to the extent offset around the coordinate pairs. So it's in the min, it's minus, so it bumps it out. If that's 2, it bumps it out 2. If it's that, it seems to be A to me on that one. Computer requests a service from another computer is, so if it's requesting the service from another computer, it is the client, right? Not the requester, but the client in this case. But requester, I think, is just meant to throw you off. The server is where you get the data from. And the processor, something doing the processing would be the requester in this case. Well, you can do client-side processing now too, which is interesting. So, which are the most important advantages of utilizing cloud infrastructure when deploying GIS? Okay, select all that apply. Important advantages. So these are the advantages. Reduced hardware purchase, that is correct. Elastic deployments. There is security, but it's not guaranteed. So those would be the two advantages to me. Collaboration barrier is obviously a disadvantage, even though I think it helps increase collaboration when you're having things in the cloud, but hey, it's not for me to say. So I think it's B and D. There's no guaranteed security in the cloud. You have security, but it's up to you to set it up. What would be the most effective and secure communication protocol to use for a web application that would still allow it to be widely accessible? It's going to be HTTPS to keep it secure, but it's HTTP, which means that it can communicate with the web. So HTTP is the answer here. I'm pretty sure. Okay, and the final question, which of the following is not an appropriate GIS professional task? So acquisition of field data to recover property boundary, collection of data related to school, georeferencing source materials, production of maps depicting for a city borough. I don't know why any of these is like not an appropriate task for a GIS professional. Acquisition of field data, georeferencing, production of maps. I think it sounds like B because you're collecting data related to that. You're kind of, it seems like it's a higher level. Acquisition of field data required to recover property boundary. Collection of, I don't know. And it seems like it's like all of them. Oh, so which one is not appropriate? Okay, so that is appropriate. That seems appropriate. Not appropriate. So I guess the field data seems like the, I hate to say it this way, but like the lowest level task, if you want to put it anyway. Like, I don't know. I think that's certainly a valid thing, but field data means you're out in the field doing this work. It's more surveying type of work, maybe not a GIS professional. So this is georeferencing, production of maps, collection. Those all seem like GIS professional tasks, I guess. I don't know why this one is excluded, but hey, once again, it's not my test. So with that, let's see how I did overall. Look, after taking the practice exam, it was like stepping into a GIS time machine for me. Some questions were straightforward, covering topics like projections, coordinate systems, and data management. But others dug into concepts I hadn't thought about in years. As you saw, there were plenty of scenario-based questions that forced me to think like a GIS analyst. How would I handle a large data set? What's the best interpolation method for a specific data? And of course, the ever-dreaded geodatabase management questions. At the end, some of these things tested areas that I haven't practiced in or different things that I really haven't used in a while, but generally I could try to figure these out by understanding other concepts or different practice areas that I've used in my professional experience over the years. And of course, as you saw, there were a few times where, well, I just had to guess. I won't lie, for me, this was challenging. It's a good reminder of how broad the GIS field really is. Of course, it's not just about maps, it's about solving problems, making data-driven decisions, and ultimately understanding how all these things work and fit together. So how did I do? Let's take a look and see my results. Okay, so final score, tallied everything up. I got 45 out of 50, which I'm actually kind of surprised about. There were definitely some that I just had to guess and reason against. I just had to kind of figure it out based on the question or the context or anything like that. And to be honest, I didn't study and I did not expect to do this well. But good news is I have clearly learned some things over the course of my GIS career. I've been doing this for a while, so it's good to know that I can kind of rely on some of that basic knowledge and apply it to things that maybe I don't do day to day. So that came out to a score of 90%. I have no idea if that's good or passing or anything like that based on what the requirements of the test are. But overall, I'm actually pretty happy with that. There are a lot of things that I did know from some of the SQL and database questions, some that were things that I thought I knew and maybe are not what mapped to the correct answers here. But overall, it was a good experience. I got to see what I do and don't know. And overall, I think I learned a little bit too going through this exam process. So to wrap up, let's talk about the pros and cons of the GISP. Starting with the pros. First of all, the GISP is widely recognized in the geospatial community. It can add credibility to show your resume and show that you're serious about your career. It's especially valuable if you work in government, consulting, or education, where certifications are more commonly used. Second, it encourages professional growth. The portfolio component pushes you to reflect on your experience, education, and contributions. It's not just about passing a test, it's about showing you've invested in your field. Third of all, depending on where you work, it can set you apart. In a competitive job market, having a GISP might be the extra edge that gets your resume noticed. Now, for the cons, it's not cheap. Between the application and exam fees, you're looking at maybe a $500 minimum investment and maintenance fees as it goes forward. You can also add in study materials or prep courses, and the cost can certainly go up quickly. The portfolio process is also time-consuming. It can feel like you're compiling a college application all over again, digging through your work history and organizing documentation. On top of that, this can be quite a lonely process. You are the one that's taking the test, building all of the documentation, and ultimately getting the certification. But at the end of the day, it's just a certification. While certification can certainly be great, I think a lot of times having a community that you can lean on, support, ask questions with, and collaborate with can be almost as valuable as a certification itself. This is something I've tried to build into the Spatial Lab, my community of spatial professionals that are looking to advance their career and stay on top of the most cutting-edge trends in the space. This allows us to work together and understand these different things as they happen and then immediately apply them to our work. And finally, it may not be entirely essential depending on the sector that you work in. If you work in private industry or technology, employers might care more about your hand-on skills with things like Python, SQL, cloud tools, or a cloud or Esri certification rather than the GISP. So it really comes down to where you are in your career and what your goals are. For some people, the GISP makes a lot of sense. For others, it might not move the needle much. So probably the biggest question, will the GISP help you land a new job or earn a higher salary? And the answer, of course, is it depends. If you're applying to roles in government agencies, large consulting firms, or organizations that value formal credentials, having a GISP can absolutely help. In some cases, it might even be required for some positions. As for the salary, some surveys suggest that GISP certified professionals earn slightly more than their non-certified counterparts. But keep in mind, certification alone won't get you a raise. It's one piece of a bigger puzzle that includes your experience, skill set, and ability to solve real-world problems. Plus, given that the GISP is meant for individuals further in their careers, the salary boost could simply be a correlation with experience. If you're early in your career or transitioning into GIS from another field, the GISP might not be your top priority. You might be better served by gaining technical experience or learning in-demand tools first. But if you're mid-career and want to stand out, or applying to jobs specifically that mention the GISP, then yes, it could be worth it. For me, taking the practice exam reminded me how much I've learned over the years and how much there is still to know. And more than anything, that made the experience of taking the test worth it. If you're thinking about going for your GISP, let me know in the comments. I'd love to hear where you are in your journey. And if you found this helpful, consider subscribing for more GIS content. Until next time.